Let's assume our application is a image compression app. So let's create a function, func, and I'm going to name it worker. And this function receives the image file, and we're just going to stick to string type for the case of simplicity, for the sake of simplicity. And then it also returns us back that image file. So our return type is of type string. Now in this function, to simulate the compression of image, which takes time, I'm going to just do time dot sleep for 50 milliseconds. So time dot milliseconds. And after that, I also want to print it out. So fmt.printf, and there I'm going to say image processed, and I'll print out the name of the image using this %s with a line break. And after a comma, I'm going to pass the image file. So to the placeholder, that %s. And because this function also has a return, this function of course has to return the image back. So I'm just going to return the image file there. Now, inside of our main function is where we are going to launch this worker. So we can do something like this, worker, and to this worker, we need to pass the image underscore one.png, which is the image we're passing. And this worker function also gives us back the file. So I can say here file like this, or maybe file one. Now, at the start of the function, I also want to see how long it takes. So I'll make a start time variable, which is going to be time.now. And at the end, I want to print it out. So I'm going to do fmt.printf. And there I want to say time taken, maybe total time taken. And there I'm going to pass this placeholder. And the value of that placeholder would be time.since that start time. And because we're capturing that file one, we should use it too. So I'm just going to say fmt.println, and I can say printf is what I should use. Image received, received, and then the name of the image file, which is that file one. And let's run this program now. So if we come to the terminal and say go run dot, we get to see that image was processed. So image1.png was processed. Then we received our image, which is this. And then the total time was this 50.68 milliseconds, and which is normal because 50 seconds of that 50.68 was just to process the image. Now, what happens if we launch two of these workers? So I'm just going to copy that part and paste here again. Now here, and here, it should reflect 2. With that, if we run this program again, we get to see something normal, that the total time was now 100.63 milliseconds, because 2 times multiplied by the 50 is of course 100, and that 0.63 is something normal for data to travel back and forth. Now, let's get something straight. Nothing, and absolutely nothing in this world, so no one thing in this world, can work on multiple things simultaneously at the same time. That is not possible. And this is then the very reason why modern day CPUs and processors evolved to have multiple cores and threads. So we can delegate multiple tasks simultaneously or concurrently, in fact, at the same time. As you saw, that two of those files together took 100 milliseconds, and that's because this main thread is running in one thread. You are a person, you cannot be here and in New York at the same time. You are at one place. So this main thread runs on a CPU thread at one time. Now we can delegate this file1 task and file2 task out of this main thread onto other computer CPU threads that we can do. And that is the reason why Go, the programming language, gave us Go routines. We can use these Go routines to take this function and launch it in a new process. And then we can take this function and launch in a new process. So for example, in your CPU, you have 4 cores. In the first core, this main thread is running. Go routine, when you add Go routine, it will take this function and launch it in second core. It will take this function and launch it in third core. So all these 3 functions are running then simultaneously or concurrently. Now, the way we launch those Go routines is that we add this Go keyword in front of it, like this. That's it. Now, the other fact is whenever you launch something in a Go routine, you cannot expect data back from it. That is not going to happen. So we're going to remove this, and we're going to remove this much. Also, we're going to remove this return back variable. And because we don't have a return back variable, there is no use of this print line. With that, our functions, so our worker functions, are now being launched in a Go routine. Now let's run this program. And as you can see, the total time taken was 0 seconds. So what's up? Now the reason why you see 0 seconds was taken, so no time was taken, is because whenever you add something to a Go routine, so whenever you launch a Go routine, Go extracts that statement out of this main function immediately. It gets extracted out and gets launched in its own process by the Go runtime scheduler. And this is where we launch, and then we have to wait. We have to wait for it to complete it, or we have to wait for it to be finished. And we wait using wait groups. So I'm going to create a new variable here, var, and I'm going to name it wg, and everything in Go has a type. And the type of this wg is going to be sync, which is a package in Go, and they're the wait group, sync.WaitGroup. And we have to launch this Go routines using this wait group. The way we do it is wg.go, and this go method takes a function, and in that function body we pass this worker function. Likewise, for the second worker, we are going to do wg.go, and instead of this go method, we're going to pass a function signature, where in the function body, we're going to pass the second worker. And with that, we can remove those. So we launch 2 of our Go routines in wait groups, and now we have to wait for these wait groups to finish, simply by doing wg.wait. Now with that, if we run our program, we now see that image 1 was processed and image 2 was also processed, but the total time taken was only 50.47 milliseconds. And that really shows you the power of Go routine, that you can spawn multiple tasks concurrently and you can save a lot of time. As you can see, 100 millisecond was slashed to 50 milliseconds because we are dividing the task in multiple computer threads, and so they can work at the same time, cutting down on the time that would take otherwise. Next, let's talk about receiving data from a Go routine. Like I said before, a Go routine cannot just return data simply like this, not by a return statement, and we cannot capture it in a variable. That's not possible. So there is no point in having this return statement and no point in having this return signature in this function. So what's the solution? How do we get data back from the Go routine? The solution is channels. And you can think of a water pipe. So a data gets pushed from one side and then gets received from the other side. Now we are going to create a channel in the main function. We will then pass it to this worker function. And then after this processing is done, this worker function is going to take that processed file and pass it through that channel from this worker function, so the go routine, to our main thread, so the main function. And so let's create our channel. We are going to name our channel result channel like this. And here then we have to make a channel. So we use the make keyword, and then we say chan. That's the keyword for channel. And this channel is going to receive string because at the end that is the file type we are working with. Now we have to make sure that this worker function is able to receive a channel. So in the parameter, let's pass it. We are going to name it result channel. The name can be anything, but this is going to be a type of channel, and the channel is going to take string, like that. Now we have to pass this result channel to this worker functions because it expects one. So let's pass it here and there, just like that. Now we created our channel, we are now passing it in the channel. All that's left is after the processing that we use this channel to pass the data back. The syntax is we call that result channel, and then using this point symbol, we pass our image file back. And because this arrow always points leftwards, and we want to pass the file into the channel and the arrow points leftwards, this is the syntax. Next, let's read the data from this channel. So after this wait group, we are going to use a for range loop. So we're going to for on the result channel, and we are going to range over it. So we're going to call this range. And actually, let's name it result, just result. And we're going to range over this result channel. And inside, we can then call fmt.printf. And there we are going to say received. And this time we're going to pass this placeholder with a break line. And we are going to get the result. With that, let's now run our program. And we get an error. So what's that? Well, first, for this result channel, we have to specify, is it a buffered channel or an unbuffered channel? And because we are passing two Goroutines into it, we have to mention two here, which then it turns this result channel or this channel into a buffered channel. On the other hand, we also have unbuffered channel, which works like a WebSocket, and that is out of the scope of this lecture. So that's one thing, mentioning how many Goroutines go there. And the other thing is closing the channel. So after this wg-wait, we have this global close function, and to this we have to pass this result channel. And together with this, so it's very important that we mention how many buffers it gets, and we also have to close the channel. That's very important. And together with this, we can now run our program. And now we get to see that the image was processed, both of the image was received, though the order doesn't matter and is never guaranteed. And we also get to see the total time taken. And with all of that, so by creating Goroutines, waiting for it, then launching it, and then getting data from it using channels, all that scenario together makes the fan out / fan in pattern. So we fan out the task that we have to launch and then read it using the fan in. And together then that creates that fan out, fan in pattern that you often hear in Go terminology. Now with the fan out and fan it pattern complete, let's move on to the second pattern, which is the worker pool pattern. Let's say we have a slice of images here, and you can think of it that we have fetched some images from our file system, which are to be processed. So two images here. And now instead of doing wg.go manually over and over again, we can use a for loop. So we can do for, and we don't need the index, and we get single image from the images. And then we want to range over the images. And then inside of this, we can then call this function like so. And instead of passing these images manually, we can simply pass this image, because this image is a string. And with that, if we run this file, so the main file, we get to see nothing has changed. Everything's working. So what's the issue? The issue is now we only have 2 images. Now, what if you have 1,000 image? You would run this Go routine 1,000 times, and that is the issue. And so next we're going to see how we should limit it, and that's the way we do it in the real world applications. All right, now to learn this worker pool, first let's discuss the whole scenario. The scenario is, for example, we have, let's say, 4,000 images. Not 4, but 4,000. And I cannot write 4,000 images one by one, so I'm just writing here 4, representing 4,000. And our safe capacity is that we process 2,000 image at a time. And so then the bigger picture is that we are going to launch this worker Go routines without any file at the beginning. So I'm going to remove these files and remove this result channel getting anything. We also don't need this, so I'm just going to comment it out for the moment. And down here, also I'm going to comment this for loops, because we're not sending anything with the channel there anymore. So the idea is that we're going to launch this worker channel, let's say 2,000 times blankly without any image file. So we're going to launch it first, and then we're going to send a maximum of 2,000 image to those worker pools, to those 2,000 worker pools. And we know a Go routine can only send or receive data using channel. So we are going to now create a new channel that will be used to send data to already launched Go routines, which it will then process, and then using that old result channel, that launched Go routine that is getting that image file later is going to then process and then send it back to the main function. So here I'm going to create a new function, new channel. Let's say job channel. And this will also get this make statement, instead of which I'll say it's a channel of type string. And the buffer size of it is going to be this len images. All right. So with that, I also said that we need to somehow limit that process. And so I'm going to create a new variable here, total workers, and I'll set it to 2. Now we will need a for loop. So for I less than 1, I equals to 1, I equals to 1, I less than or equals to I less than or equals to the total workers, I should get plus plus. And now from within this function, I want to launch this Go routine. So I think it should be like that. Yeah. And now we are no longer sending this result channel anymore. Or are we? Yeah, we are sending that result channel, but we also have to send that job channel. So I'll get this job channel, which is also a channel of type string. So we use this job channel to send data to already running Go routines. As you can see here, this is a running Go routine, and it doesn't get that image anymore. It gets that result channel and the job channel. So the result channel and the job channel. And you see now we are launching Go routines without any image file. It just has 2 channels. So the Go routine gets launched, and then using this job channel, we will send the image later. And after that processing is complete, we will use this result channel to get data back to the main function. Next, we also have to wait for this and close it, but not like this anymore. We will grab it out of here and we are going to launch Goroutines. So a Goroutine, and we have this func. Of course, we have to make it anonymous. So we do this, and therein we are going to do that wg.wait, and we are also going to call that close again, which was for that result channel. So that we already have before, but now this should go inside a Goroutine. With that, now we can launch the jobs. So next, let's do a for, and I, let's say, equals to 0, I is 0, I less than, let's say I want to learn over that images, and I should be plus plus. And from this for loop now, we are going to call our job channel, so the job channel that we created, and to that we are now going to pass each of those image. So not like that, but a job channel, and to this we are now going to pass each of our image. So we are getting our images, we have our images, and we can index it by the eye. So there we have it. What's all this typo? Right, so there, then we are then launching our images using that job channel to the already launched Goroutines. And because we are launching things to this Goroutine, we also have to close it. So next we're going to call this close, and to this we're going to pass our job channel. Next, let's work with that worker function up there. So now within this function, we are going to iterate over the jobs. So let's say for job chan, I want to range over the job channel that we have. So we are getting. And there now we want to process. So we're sleeping. And also there is where I now want to do my FMT print line. So just like that. And instead of this image file, we are now getting that each job. So maybe we can just say job instead of job chan. And with that, after it is complete, we can then call our receive channel inside of that for loop. So we get our receive channel, and inside of the receive channel, we can then pass our job. So the job that we are currently iterating over. So now with that, let's run this program. So we say go run dot, and if I increase it, you see I get image file 1 received, processed, received, processed, received, processed, processed, received, received. And so that was it.